Okay, this max area thing. You are given an integer array of height of the n vertical lines such that the two endpoints are I0 and I height. What does that mean? Oh yeah, okay. Find the two lines together with the x-axis. There are n vertical lines drawn such that the two endpoints of the ith line. What the heck does that even mean? Is given by I0. And I. Oh, okay. That's I0 and I. Okay, yeah. Such that the container contains the most water. Okay then. And I presume the value between the two 8s is not possible because 8 and 8 would give you how much water? So 1, 2, 3, 4. What? So the minimum between them wait, 1 7 1 2 3 4 5 6 7. Okay, yeah. And then the highest between them is just 7. Okay. So contains the most water. You may not slant the container. Sure. Okay, so I guess the left and the right, they have to just point to the constraints, just they need to point to the highest values. Okay, so I just need to think, it's like, if I'm moving the pointer, how much water am I... So with the height 1, 1, what will that even look like? It will look like the most water you can store inside is just 1. Okay, so this is definitely what you have to return, man. And then only problem is, how do I get to that value? Let's start with a smaller situation. How can I figure out the most water I can store? So from the left to the right, the maximum amount of water you can store. So between the first two, the maximum amount of water you can store is just 1. Between the first 3, the maximum amount of water you can store is going to be 6. The only problem is, how would I know that it's 6? Because if, let's say, I had a situation like 1, 6, 1, 1, 1, 1, 1. So what will happen is I'll have straight line 1, 6, 1, 1, 1, 1. Like this. Well, the maximum water you can store here is 6, but the maximum water you can store between these ones, 1, 2, 3, 4, 5, would also be 6. If it's also 6, then how can I figure out, well, how can I figure this out with 2 pointers? Is this thing not starting? Minimum of the heights. Okay, so between these two I can only store 40, but then for these two I can store or maybe I can just do what I can do is I can just figure out, well, how much water I can store behind me, what is the maximum amount of water I can store in front of me. So for this one, so the maximum is going to be either just L minus 0 times height. It's always just going to be L minus 0 times height. There's always going to be that, or it's going to be between the current minus for C in range 1 height. But how's that going to help solve the problem at all? So for C in range 1 to the length of height, we can do max water has to equal to the minimum potential. It has to be water. You can just do max water equals to 0, and then maybe here we can use this return max water, and the idea is that, well, as I'm looping across, let's say when I go from here to here, the max water will just be 1 because it has to be the minimum of potential equals the height C, and then height L. So L can represent the highest index we've seen so far, minimum, multiplied by C minus L. And then now we have to ask ourselves, like the furthest to the left, it always has to be situations that if you're on any current index, the maximum amount of water that you can store to the left of you, at least, to the left of you, well, you're always limited by how high you actually are. Like for a given value. If it's a less than, which is going to, the potential is going to be 1 multiplied by C minus L. The farthest has to be between the I still don't really get if my formula is going to work or not, because 0, 1, if it's just to the left of it, 1, like over here, just take a moment to actually think about it. So the maximum water Now the only problem is, how can I find a way to maximize the minimum between the height left and right, and then the distance between R and L? Okay, so whatever value you're on, the R has to be a greater value than the current value. Okay, no, this should make sense. So for C in range 1 to length height, let's say you start off at 1, well, the potential, the water that you can get is going to just be min C minus L. Right? And then where L represents the highest value, and then we can do if potential is greater than max water equals to potential, and then we set R is equal to C. And then after this we do if height of C is greater than no, this is not gonna work. I am really stuck here. So because like my problem is because the right pointer is easy enough. The right pointer, I can just do this basically. Now I can just keep looping through, but when should I be moving the left pointer? When should I move both pointers then even? Because I have no idea. could be very well the case that how can you systematically try every single pair then? Honestly, I have no idea how to do this. Let's just take a look at the solutions. We want to keep the taller height between the left and the right. But why does that work? Okay, so while left is max area is equal to 0, so while left is less than or equal to right, we can calculate area is equal to the minimum of and then we do max area is equal to max of max area and then this area. Cool. And then we do if IL is greater than pi r, then we can do r minus equals to 1. Else we can do otherwise we can do L minus equals to 1. No, when they're on the same size then the area is going to be 0, so it doesn't even matter. And then here I can just return max area. Index is out of range. Why does this work though? Okay, I'll leave it at that, but I'm gonna have to figure out why this works.